Hello, folks. So, welcome to part 21 of Learning Rust series. This is part of my 100 days of Rust, and today I'm on like day 10, and the last exercise that we did was around arrays. So now I'm gonna go ahead and remove this I'm not done so that we can go ahead to the next exercise. Let's see what's that. Um, okay, so there's a primitive dice 4. Expected expression found question mark. Okay. So let's go to this. There's no error code, but we have seen this error before. I think we'll just have to write some code over here. Create a slice out of array A. Okay, so the A is the name of the array. Array A, where the triple question mark is so that the test passes. Execute reference hint or use the hint what's the one. Okay. So the test is basically 234. Nice slice. Basically this. So how do you get 234? I think you can use indexes or indices. So 2 starts from this, and then we can say including 0, 1, 2, 3, including 3. Does that work? Okay, expected semicolon found as it. Okay, so we have to actually put a semicolon here. Okay, so size for values of type integer cannot be known at compilation time. Doesn't have a size known at compile time. Okay. So consider borrowing here. Okay. Can I borrow here? I don't know what borrowing means really, but it passes. But if I say this, what does it do? That all local variables must have a statically known answers are treated as an unstable feature. Okay. Can I provide the size as 3 over here? Is that okay? Expected wait, expected one of dot question mark. Okay. Data found. Okay, that's right. So, interesting. I guess we'll just have to say borrow, but I don't know what that means really here. I mean, I've heard of ownership, borrowing, and whatnot, but I have no idea what it means here. Let me just do a hint to understand what's going on over here. Maybe I'll just type hint. Take a look at the understanding ownership slices, other slices section of the book. Okay. And use the starting and ending indices of the items in the array that you want to end in the slice. Okay. If you are curious why the first argument of the author does not have an ampersand for a reference, since the second argument is a reference, take a look at the coercion chapter of the Nomicon. Okay, I don't know what's that, but you can go ahead and check it out. I'm guessing there might be some interesting things in even Ruslin's hint, primitive types 3 also, primitive types 3. This is shorthand to initialize arrays with a certain size that does not require you to type 100 items. But you certainly can if you want. For example, you can do this. One is what are some other things you could have that would return true for a right line. Okay. You could have an iterator thing. Interesting. So now I'm gonna go ahead and check out these. One moment. Let's say this, and then oops. Of course, gonna go ahead and run this, and then coercions. Right. So let's check out these two. So chapter 4, 3 sizes. Okay. 4.3 slice type. Okay. We still haven't learned ownership actually speaking. Not sure if it will come up. Let's see if it is there. Rustlings, help, list, owner. Nope. There's nothing around ownership. So I think we'll have to just learn it on our own. Okay, so let's see. Common programming concepts, variables, immutability. By default, it's immutable unless you put mute or something like that, or if you use constant. Functions, comments, control flow. Okay, I think understanding ownership is something that I'll have to look at. Maybe I'll start here. Ownership is Rust's most unique feature and has deep implications for the rest of the language. It enables Rust to make memory safety guarantees without needing a garbage collector. So it's important. Okay, so there's no garbage collector in Rust. Okay. I still have to dig deep into this, but I think what this means is basically there's no process running along with your program that's looking at what are the variables that are not being referenced and used and like removing it from the memory and like cleaning it up. Instead, like as in doesn't have like a built-in garbage collector that checks all these stuff. Instead, I think it's all part of the program where it takes care of the program itself takes care of freeing the memory as and when it's does not need the variable. So I think the compiler itself puts some malloc like memory allocation and free and whatnot. At least that's my guess, but I have to check it out. So it's important to understand how ownership works. In this chapter, we'll talk about ownership as well as several features, related features, borrowing slices, and how Rust lays out data in memory. Okay, so we are learning about borrowing slices and how Rust lays out data out in memory, lays data out in memory. So what is ownership? Ownership is a set of rules that governs how a Rust program manages memory. Okay, so it's a set of rules. Uh-huh. I believe this is like the heap for the RAM memory, but you'll have to check it out. All programs have to manage the way they use the computer's memory while running. Some languages have garbage collection that regularly looks for no longer used memory as the program runs. In other languages, the programmer must explicitly allocate and free the memory. Rust uses a third approach. Memory is managed through a system of ownership with a set of rules that the compiler checks. Okay. Um, If any of the rules are violated, the program won't compile. None of the features of ownership will slow down your program while it's running. Okay. Because ownership is a new concept for me, just takes some time to get used to. The good news is that the more experience you become with Rust, the rules of the system, and the rules of the ownership system, the easier you'll find it to naturally develop code that is safe and efficient. Keep at it. In understand ownership, you'll have a solid foundation for understanding the features that make Rust unique. Okay. In this chapter, we'll learn ownership by working through some examples that focus on a very common data structure, strings. Okay. So before we go there, stack and the heap. Many program languages don't require you to think about the stack and heap very often. Okay. But in a systems programming language like Rust, whether a value is on the stack or the heap affects how the language behaves and why you have to make certain decisions. Okay. So looks like we have to look at these two things and we should understand whether value is on the stack or the heap and how it affects the language and how it behaves and why you have to make certain decisions, right? Parts of ownership will be described in relation to the stack and the heap later in this chapter. So here is a brief explanation and preparation. Okay. Both the stack and the heap are parts of memory available to your code to use at runtime, but they are structured in different ways. Okay. The stack stores values in the order it gets them. Okay. So mix in stack, it's the name itself, like stack, queue, stack. You push, one is on the top and then pop from the top, you blah, blah. In order it gets them and removes values in the opposite order. So first in, last out, right? Or last in, first out. So this is referred to as last in the first out. Think of a stack of plates and you add more plates, you put them on top of the pile, and when you need a plate, you take one off the top. Adding or removing plates from the middle or bottom wouldn't work as well. Okay. Adding data is called pushing onto the stack, and then removing data from is called popping off the stack. All data stored on the stack must have a known fixed size. Okay. Data with an unknown size at compile time or a size like at compile time, let's say you get a user input and you don't know the size, or a size that may change must be stored on the heap instead. Okay, so heap is less organized. So one moment, someone's at the door. I was on mute the whole time. It's fine. Right. So each one moment. Okay, each value in the Rust has an owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. Okay, so hmm. So each value in Rust has an owner. There can only be one owner at a time. Okay. When the owner goes out of scope, the value will be dropped. Okay. At a time, there can only be one owner. Okay. Interesting. So there can't be many owners at a time. Each value in Rust has an owner. When the owner goes out of scope, the value will be dropped. I think I'm gonna go ahead and check out this whole thing offline and then record. And maybe do some explanation and whatnot, like and see how that goes. Because I think there's going to be a lot of information that I need to actually process and understand. And I also realized like I recorded a lot of myself being on mute because of this thing. If I pull it up, it just means me. So yeah, but as of now, we have finished this exercise and we're good to go with the next exercise. But I want to learn what this whole ownership thing is about, because in the next few exercises, I'll probably need them, I think, or I'll surely need them because it's apparently a basic foundation. So yeah. So that's all I had for this video. I'll see you in the next one. Bye-bye.